This is Precalculus, lesson 3.2, homework help. So we'll start with problem 13. I'm going to show this to you. It's a picture of what the problem is. And the question is it a function or not? If we just consider the vertical line test, it's a function, because even if I do a vertical line here, it only intersects here. It doesn't intersect here because it's an open indicator. So anywhere I draw a vertical line, it would pass the test. Even here, that means it's not equal there, so hasn't intersected it yet, intersects it here. That passes the vertical line test. All right, number 17. I have graphed, and it wants to know on what range is this increasing, decreasing, or constant, this function. And if you look at the graph, all the way up to -1, it's constant. And from -1 to +1, it's decreasing. And from +1 all the way to positive infinity, it is constant. So negative infinity up until -1, constant. -1 to +1, decreasing. +1 to infinity, it's constant. That means the y value is not changing. All right, number 21. Number 21, I'm going to put in y sub 1 on my calculator. It's 0.2x to the 4th power minus x cubed plus x squared minus 2. Oh, well, I have to clear it because I put all of it in the exponent. Let me go back. 0.2 x to the 4th, I need to go over, minus x cubed plus x squared minus 2. So I put that in my calculator. I graph it. All right, it does look like a 4th degree. And the question is estimate all the local maxima and minimum. All right, so I would say there's a minimum here, and then it goes back up to a maximum to a minimum. So I'm going to make my window for x a little closer, maybe -4 to +6 to help me see it better. Yeah, see, I can see it better. Then I'm going to do second trace min. Second trace min. Okay, my marker's here, but I want to go back this way. I'm watching my y values. This is hard to do backwards. That seems like that's the min. That's -1.901. That's a smaller negative. All right, let's see if I can, 901, 92, 99. There, it just got smaller. Okay, so the min actually is right there. All right, so that's bigger. I'm gonna go here. That's gonna be my left bound. All right, so that's my minimum. I do the same thing over here, watching my y values. I'm thinking there's a maximum right there. So I'm going to do second trace maximum. I'm watching my y values. Okay, remember, all right, smaller, 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 still smaller, smaller. Wait, that got bigger. Okay, so it's got to be right here. See, I'm watching the y value. All right, and I would do the same here. This has got to be a min, all right? That was number 21. Number 27. It says estimate all the max and the minimums. Same thing. I'm going to put it in my calculator. All right, so that's x cubed minus 1.8x squared plus x plus 2, making sure my window is negative 10, 10. All right, so you're going to see it graph the first time. Okay, I'm going to pull in tight here because I believe there's probably a maximum there and a minimum here. So I'm going to change my x window. I'm going to get maybe negative 4 to 4. There we go. All right, so it starts here and goes up here. So that's going to be a maximum. I'm going to do second trace max. Second trace maximum. I'm going to go back and watch my y values. Okay, they're getting bigger, 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 bigger. Wait. Nope, still bigger. Maybe we don't have a, wait. All right, that's it. That's big. Let me just look at this. I'm struggling with my eyesight. Yeah, it gets bigger and smaller there. See, it goes from 2.171. It gets bigger and then goes back smaller. All right, so I'm going to go back a couple. That'll be my left bound. I had my eyes dilated, so I'm having a hard time seeing. All right, so that would be your maximum. You'd follow it through and look for a minimum right here. Okay, that's 27. 35 says, find the approximate intervals on which it's concave up and concave down and estimate the inflection points. So 35, I'll graph again. X to the fourth minus 2x squared right. Okay, I'm going to go back in closer so I can see it. All right, so I look like I have a min, a max, a min. All right, I'm going to get closer in my window. And I'll graph it. Helps us to see it a little better. All right, then I'm going to do second trace min. Second trace minimum. Again, I'm going to go watch my y values. All right. Getting bigger. I think it just got smaller. It did. Bigger, smaller. All right, so I'm going to hit enter there. Go over 1, 2, 3 at least. Enter. Guess. Okay, so it's where x equals -1. So it's -1, x equals -1. We have a minimum at x equals -1. All right, we're just going to do this part and decide concave up. So that's a maximum. I'm doing second trace maximum. Watching my y values. They get smaller, smaller. I'm going to keep going. Smaller, smaller, smaller. 0. Okay, bigger. So it's right at 0, I think. That's my left bound. That's my right bound. X equals Okay, look at that. It's x equals that -1 to the e to the -6. That's 0. Okay? So I'm going to say there's a maximum at x equals 0. All right, the point of inflection is where it changes concavity. All right, so remember, the point of inflection is when I add them and I divide by 2. So that 0 plus -1 over 2, which is -1/2, is my point of inflection. So it's going to be concave up, all the way from -infinity up to -1/2. -1/2 is where it begins to concave down at -1/2. All right, we need to go find this other min. We need to find this other min to see where it's concave down. And so I would find this min, take the average between the max and the min. That would be a point of inflection. So it would be concave down from -1/2, probably to +1/2. It's just my guess, because I bet there's a min right here at +1. All right, that's 35. 41 says sketch a graph. All right, so we will sketch a graph of (2x plus 3) when x is less than -1. I thought we did this one in class. 2x plus 3 when x is less than -1, and x squared if x is greater than or equal to -1. All right? So we're going to go all the way up to -1. All right? So let's see what this would be at -1. If that's -1, that'd be 2 times -1 plus 3, that'd be +1. But there's going to be an open indicator. All right? So now let's go back to -2. 2 times -2 plus 3, that goes to -1. So when x is -2, y is -1. All right, so it's linear. So it's going to go that way. Now this begins to be x squared. So let's start plugging in. When x is -1, y is 1. So actually that is going to be a closed indicator because it does equal it. At 0, it's going to be 0. At 1, it's going to be 1 because 1 squared is 1. So then this looks like that. It's a parabola.